Hi everyone, in this video we're going to finish up 8.3 on trig integrals. So we initially talked about 4 different types of problems you'll come across in trig that have to do with trig integrals. And so in this last video for this section we're going to look at part 2 and part 4, part 2 being eliminating square roots. So picking up in our examples, this is example 7 technically. And so we have this integral that has a square root with a trig function in the inside. And so basically what you want to do here is you want to think, well, how can we get rid of the square root? Is it possible? And in this case it is because of what's inside. And you have a whole lot of trig identities, and you kind of want to look at a list of them and then think about which one's going to help you here. And so I'm going to show you what's going to work out here. So one of your identities, and it's come up a few times in previous examples that we've done, is cosine squared of x equals 1 plus cosine 2x over 2. Now why this one's going to help us out here? It's because what we have in our radicand is similar to what we have in this identity, and this identity also has something squared in it. So putting this together, if I can rewrite this identity to match this radicand, then hopefully I have something squared that I can take the square root of. So we want what we have in this identity to match this. Notice the difference is this 2 on the bottom and then this 2x here. So let's start by timesing both sides of this equation by 2. That's going to be the first easy part to rewriting this identity. So 2 cosine squared x is just 1 plus cosine 2x. And then the next thing is we don't have a 2x, we have a 4x. So instead of having a 2x here, well, how do I change this? And if the x's are going to confuse you because this is an identity with x's in it, but your actual integral has x's in it, just change this. Change your identity to a different letter if it's going to help you. Okay, so let's just call that a. And then I'll go ahead and go back and call this a back here just to make it all match. So then what we have is a 4x where the formula or identity has a 2a. And so then we know that 2a is the same as 4x because if we're matching this up. And so how do we address this over here? Well, if you just do a little quick solving, divide by 2, a is 2x. And so over here on this left side, we can now rewrite our identity and say that this is, in our case, so let's just put it all together. We have 2 cosine squared of 2x equals 1 plus cosine of 4x. And then this was our radicand, and we can now rewrite it using our identity. And so let's just plug this right in. We have the integral from 0 to pi over 4, so this equals from way up here, square root 2 cosine squared of 2x dx. Okay, because this matches this from our formula here. And now the good news is this quantity is squared and we can take the square root of it. So first let's factor out the square root 2 because it's square root 2 times this cosine squared. So I'm going to factor out that square root 2 all the way to the front. And then this is now square root cosine squared 2x. And then we can go ahead and take the square root. I'm just leaving the limits of integration off for just a second. And then this is square root 2 integral of cosine 2x dx. Alright, let's put those limits back on. Alright, and now this is very nice. We square rooted the squared item. And then you've seen this a lot now. At this point, you can use u substitution. U is 2x, du is just 2 dx, so you'll substitute 1/2 du for dx. And so let me just move over to the left here. This is square root 2 times this integral from 0 to pi over 4 cosine u times 1/2 du. Okay. Now I am going to run out of room, so let me go ahead and move this up. Okay, so continuing from where we were just at, just moving it up, factored out the 1/2 to the front. This is now, if we're ready to integrate, integral of cosine u is just sine u. But actually, let me make this very clear. These limits of integration were in terms of x. So back here, I can't plug those in for u. I don't want to accidentally think I need to plug in for u. So I'm going to go right back to what x was. X was, or u was 2x. So this is 2x. And now our limits were in terms of x from 0 to pi over 4. So then let's evaluate this, and then we'll be done with this one. So square root 2 over 2, let's just leave that factored out. This is sine of 2 times pi over 4. Let's just put parentheses around that. Minus sine of 2 times 0. Okay, so leave this square root 2 over 2 factored out. This is sine of, the 2's divide out, this is sine of pi over 2. Minus sine of 0. Okay, and then from our knowledge of trig, using our trig unit circle, or however you recall this, this is going to be square root 2 over 2. Sine of pi over 2 is 1. Sine of 0 is 0. Final answer, square root 2 over 2. For our last part for this section 8.3 on trig integrals, we have part 4, products of sines and cosines. So this is when our integrands have sines and cosines being multiplied, but they don't necessarily have powers on them. We went over that in part 1. So we can use integration by parts. You can, yes, but you'd have to do it twice. So it is long. And so what I'm going to say here is that it is simpler to use identities. Okay, so we are going to use some trig identities. I'll list them for you here, and then we'll talk about them. Okay, so here are the identities that are going to be easier to use than trying integration by parts. Now, these are lengthy to memorize, so it might be best to have these available to use. And if you don't have them available or you can't use them, integration by parts will work. So what this has is if you're starting with the product of sine times sine, or sine times cosine, or cosine times cosine, you can rewrite that product in terms of a sum or difference. So this is like a product to difference or product to sum formulas. And so what you have here in the first one, I'll call it part A. Basically, if you recognize the coefficients on x in the first factor and the second factor, they go into the argument of cosine here in part A. So it equals 1/2 cosine of whatever number m is minus whatever number n is. That's going to be times your x. And then minus cosine, and then you add this number m plus this number n times x. And then very similarly for your other formulas, just notice the differences. When it's the sine times cosine formula, you have signs in this right side of your equation here. So sine of n minus n times x, and then plus sine times m plus n. And then the last formula, what I'm calling letter C, is cosine times cosine. The formula has both cosines in it, just like formula A, but notice the only difference is the plus sign. So this last formula has a plus sign between the two cosines here. So let's try this out. We're going to use this idea in our very last example from this section. I'll call it example 8 because we did 7 already. And we're going to integrate sine of 3x times cosine 5x dx. Alright, so basically if you can recognize what m and n are, you can sub them right in. So m is 3 for us, okay, because this is, well actually first let's identify which of these 3 versions of this identity we're working with. We are working with B. So we are working with letter B here because it's sine times cosine. So m is 3, and then n is 5. So n is 5. Okay, and so basically everywhere in this right side of the formula we're just going to replace m and n with 3 and 5. So this integral, we're just changing the integrand. So we still have our integral symbol, and this becomes, and you can factor out the 1/2 actually, let's go ahead and do that. So 1/2 out front, this is going to be sine of m minus n, but this is all times x in terms of sine, so be careful here. I'm going to use brackets just to clarify what I'm saying here. You are subtracting, yes, timesing by x, but all of that is part of the sines argument, so make sure you don't think the x is like separate out there. So m minus n. Okay, and then from our formula, plus sine of m plus n times x. So 3 plus 5. And this was our integral, so dx. Alright, so this is so much nicer to work with. We have the integral of, 1/2 times the integral of sine negative 2x plus sine 8x dx. And from here we can just use u substitution and figure this out really quick. So if you want to, go ahead and pause this and try this out. We know how to do this pretty well at this point. Just use u substitution, and then I'll show you the answer in just a moment. Okay, finishing up this example, picking up right from where we were at, using u substitution, in the first integral I just separated it into two integrals. Let u equal negative 2x, so we end up subbing negative 1/2 du for dx. Second integral, let 8x be u, so substitute 1/8 du for dx. And so we have, and I distributed this 1/2 to both integrals when I just made them two integrals here. So what we have here is 1/2 integral of sine u times negative 1/2 du. And then over here plus 1/2 integral of sine u times 1/8 du. And we get negative 1/4 integral of sine is negative cosine. Let's go ahead and sub in what u was again real quick. So just to save some time, u, it would have been negative cosine of u, but u was negative 2x. Okay, and then over here, plus, let's go ahead and take out the 1/8. That's 1/16 negative cosine. In this one, u was 8x. And let's make this just look a tiny bit better. This is cosine negative 2x over 4 minus cosine 8x over 16 plus c. Final answer, and we did it.